So today in Math 3, we're going to look at the inverses of exponential functions. These have a specific name. We're going to get into it in a little bit. All right, so consider the two tables that we have on either side of the graphs, and the blue and the red graph. Okay, so we have our function, which is right here, f of x equals 2 to the x. And the values for that are over here. So if you put in the x values here, you get in their corresponding y values. So 2 to the negative third gives you 1/8. 2 to the negative 2 power gives you 1/4. 2 to the negative 1 power gives you 1/2. 2 to the 0 gives you 1, so on and so forth, all the way to give you all the points on the blue line. Excuse me. Now, we've already dealt with inverses in the last unit, and we saw that when we had the tables, we just switched around the table of values. So what was f of x on the left side over here, and all of its table of values, now becomes the x values. Now the x values on the first table all become the f of x values of the inverse. And then you get your red line. Okay, so you're just reversing all the terms, all the points, flipping them over, and then graphing your line. This is its inverse. So let's look at the characteristics of the inverses and the exponential functions. Now the exponential functions we've already been dealing with now from the first topic. You should have taken a formative on that already. So the domain, the x terms that exist for the blue graph. Let's put this as blue. This is the blue graph. I'm going to say this is the red graph. So for the blue graph, the domain is from negative infinity to positive infinity. So the whole value of x's exists for the blue graph. Now the range is different. Remember, it gets close to 0, but not totally 0. So it goes from 0 up to positive infinity. The asymptotes are that x-axis, which is going to be y equals 0. The x-intercept, well, there is no x-intercept. Okay, that graph does not cross, the blue graph does not cross through the x-axis, so there is none. Excuse me. The y-intercept, on the other hand, there is one. And it is 1. You can see it right here. 0, 1 is the y-intercept. Because when you raise the number, in this case 2, to the 0 power, you get 1. All right, again, we've seen this in the last topic. Intervals of increase or decrease, well, in this case, it's the growth function. It is increasing over the entire domain. Okay, and then finally your end behavior. So as x approaches negative infinity, the graph is going towards 0. Okay, we can see that right here. So as the graph approaches negative infinity, because it's going this way, it's getting closer and closer to 0. It just won't actually touch it. On the other side, though, as the graph goes to the right, so as x approaches positive infinity, the graph is going up towards positive infinity. Okay. Now let's look at the red graph, the inverse of our exponential function. So the domain, what x values exist in this graph? Well, it looks like the x values start actually at 0 and go towards infinity. Nothing on the red graph exists over in this area. So our domain is going to be kind of like the range of the blue graph, 0 to infinity. Okay. Whereas the range of the red graph starts way down low and keeps going up higher, so it's going to be from negative infinity to positive infinity. So it goes from the bottom to the top. Okay, notice how they're just reversed of the domain and range of the blue graph, the regular function, exponential function. Okay, the asymptotes. Now in this case, the asymptote is here on the y-axis versus the x-axis for the blue graph. Okay, that gives you a different equation. That would be x equals 0. For the x-intercept, this time you can see it right here. You have 1, 0. And for the y-intercept, because it goes close to the y-axis but actually doesn't actually touch it, There is no y-intercept. Okay. This one's a little bit trickier. The intervals of increase or decrease. Well, this case, it is increasing the entire time, but it's not across the entire domain, because the domain for this graph is only 0 to pi. Or sorry, 0 to pi, 0 to infinity. Okay, and our end behavior. Okay, as x approaches to the left, negative infinity, the y value is approaching 0. No, it's approaching negative infinity. Wait, hold on. I messed that up. The x is not approaching negative infinity because the x can't go that far. The x is approaching 0. My apologies. And the f of x, the graph, as x approaches 0, the f of x is going towards negative infinity. Okay, on the other side, as x approaches infinity, oh, that's an ugly infinity, the graph is going up, also towards infinity. Okay, so those are characteristics of our exponential graph and its inverse. Now the inverse, as I had mentioned before, has a specific name, and that name is a logarithm. Okay, logarithms are used to solve equations where the exponent is a variable, okay, and you don't know what it is. Okay, now you can go back and forth between exponential and logarithmic equations, but sometimes you just have to use logarithms. Okay, that's for a different time. So how logarithms work, defined by exponential functions. Okay, so you have the log of the base. The base is this, the b value. So the base of a log is like a subscript. It's lower than the g of the log of y. Log base of b. Excuse me, sorry. Log base b of y equals x. Okay. So if you're going to go back and forth, we can do the same thing for both, and we're going to show you that next, converting between exponential and logarithmic equations. Okay, we'll go back and forth. So for here, if this is our exponential equation, you're going to have log base 3 of 81 is equal to 4. All right, you notice the base of the log is the base of the exponent. The exponent is 4, the base is 3, and 3 to the 4th power is 81. On the other side, the base is 12, and the 2 is the exponent. 12 squared is equal to 144. Next, we have the log of 4. I'm sorry, log base 4, my apologies, is 16. And then equals 4. Oh, I'm sorry, equals x. I'm losing it. All right, next one. You have 3 equals x to the 7th. Okay, now this particular problem right here is a problem that you would solve using logarithms, okay? Because a regular number to the 7th power does not equal 3. Okay, so that's going to be some kind of weird decimal. So this is where you'd use a logarithm to solve that equation. That's for a different day, but that's the idea. All right, moving on. We have log base x of 1,000 equals 3. Okay. 3 is equal to 13 to the x. Log base 10 of x equals 5. All right. Next, we have... Now, this is an interesting part about logs. you'll notice for all the problems we've had so far up until this one right here, we've always been given a base. Well, if you're not given a base, if there's no base here, it's automatically assumed it's a 10. Okay, much like when we did square roots. All right, a square root has a 2 there, we just don't write it. Okay, so if a log does not have a base, it's automatically going to be 10. So we would have 10 to the pi power equals x. Okay, so the one before this, log base 10 of x equals 5, we didn't have to necessarily write the 10. You can, it's not wrong, but you don't have to write it. Okay, next one we could write it as log of 12 equals x. Notice we didn't write the base of 10. We didn't need to because it's automatically assumed that it is. Here we have 10 to the x equals 7. All right. Now the other thing about logs is there's something called a natural log, which we're going to get to in just a second. You can see it down here. Natural log uses a base of e. E is a number. I'm pretty sure I've mentioned this before. E is a number much like pi is. Pi is 3.14. E, I think, is 2.78. And then there's a bunch of different decimals behind it. Okay? But if we're using e, it's something called the natural log, which is what this ln is for. Okay? So if we have e here, we would write the natural log of 24 equals x. Okay? But the fact that we're putting natural log, it means we're using e as our base. This would be e to the 19th equals x. This is the natural log of x equals 15. And lastly, we have e to the x equals 77. So those two things I mentioned up above about the base of 10 and the natural log are listed right there. All right, and that is it. That is converting or seeing the inverse of exponential functions, which are logarithms. All right, please really try the practice. Study up for the test you haven't taken. Go to the weekly agenda page. Click on the How to Pass Math 3 link. Work on some review. Look at one of the videos for the review key. And let me know when you're ready to take a test that you haven't taken yet to try and get closer to passing before we run out of time. All right, good.